In this video, we will configure Ospf routing between our PAN and our LAN network for exchanging routes dynamically. And this here is the design of how we will configure Ospf on our network. In terms of the details, we will configure an Ospf backbone area, which is area 0 between the PAN and our core switch across that connection that you saw before. And this is the network for that particular interconnection. Off of the core, we have our user network and we have our server network, and each will belong in their own different area. When we complete that configuration, a neighbor or a adjacency will be established between the core and our firewall. That will allow our core switch to exchange its routes from area 101 and area 201 up to the firewall. And our firewall will be advertising a default route to the core. So that means that our users and our servers, if they need to access the internet through the untrusted network, then they will use the default gateway that exists on the core, which will be learned dynamically from the firewall, which means it will route up to the firewall and then use this firewall's routing table. Therefore, let's begin our configuration, and a larger version of this picture is available in your package. So let's move this aside. Before we configure Ospf on our firewall, we need to configure it on our core switch. Let's bring up the console to our core switch. Here we are, our Cisco core switch. And let's quickly show you how our two networks are configured. So the first one is our server farm network, which is in VLAN 201. So this is how it is configured, and this is the IP address our servers are using for their default gateway. And here is the user network and how that is configured on our core switch. And here, that address is used for the default gateway for our user devices. So that's how everything's configured. And this is the interconnection that connects up to the Palo Alto Network's firewall, which is on port 12. And here you will see that IP address where 99.1 is configured on the firewall side based on our design. But those three networks will be configured as an Ospf area based on our design. So for the user network, it will belong into area 101. Our server farm network will belong in area 201, and our port in port 12 will belong in area 0. So it's good to look at those details and defining what those networks will be that we will use with our Ospf configuration. Okay, let's start the Ospf configuration on our core switch. To do that, let's go into our configuration mode. And the first thing that we need to do is enable the Ospf routing process. We do that by typing in router, Ospf, followed by a unique process ID, some local identifier. It could be any number that we want. It does not need to match what the firewall will have. And we're going to use number 2, something simple. Okay, so now we need to list all of our networks based on our design that we showed you and put them into the appropriate area. So the first one will be the interconnection, which will be in area 0. So we'll first say network, then we'll define that network of 172.17.99.0 and the inverse wildcard mask for a /29. And that will be 0.0.0.7, and we'll put this into area 0. Okay, now we will add our server farm network. So that will be network 172.17.201.0 and a class C wildcard mask. And that will belong in area 201. And finally, we'll add our user network into area 101. Our wildcard mask and the area. Great. So we're done with that. Let's exit out. Let's actually do one more thing that we forgot to do as a best practice. Let's go back into our configuration mode. And then back under our routing process. And what we're going to type in is the following command, which is passive interface default. Now doing that means it will turn off OSPF functionality on all interfaces, layer 3 interfaces on our core switch. And here's the reason for that. Now based on our design, we only have one OSPF neighbor established, which is between our firewall and our core switch. Nothing from user network, nothing from the server network. So that means that routing can only be exchanged from this interface to this device here. And that's what passive interface does. It helps to prevent, let's say, the following situation. There could be a user that could have their own router. They plug it into their wall jack, which means it's plugging into the user network. And if they know just a little bit of details, if they just list this network and area 101, that will establish a neighbor with our core switch. And that could potentially compromise and bring everything down in terms of your routing infrastructure. So that means that there should be no routers within area 101 or area 201. So that means we will still advertise these networks, but if there's any potential OSPF routers, we will not communicate with them or exchange routes with them. Therefore, we want to turn off passive interface on this interface here, port 12, that connects to the firewall. So to do that, let's move this aside. And within our configuration here, we'll go ahead and type in no passive interface FAS Ethernet 1012. Okay, so we are done with all of our configuration that is needed for OSPF. And if we type in show IP OSPF neighbor, you'll currently see we have no neighbors established because we have not yet configured OSPF on our firewall. To do that, you need to make sure that we're under virtual routers, which is under network. And from there, we need to go to our custom virtual router that we added earlier, which is RHVR. Here, let's go to the OSPF tab on the far left. And here, we need to first enable OSPF. So let's do that by checking this option here. Next is the router ID, and that is used for building the neighbor with our core switch to exchange route information. So we're going to use the IP that is configured on our LAN facing interface, and that will be 172.17.99.1. Once we're done with that, we need to add a new area to our firewall based on our design. So we're going to go to add, which is under areas. Now the first thing that we need to do is define the area ID, and that will be area 0. Now on the Palo Alto Network firewall, you cannot define some number like 0 or 122 or anything like that. It must be written as if it is an IP address in a decimal format. So for area 0, you actually would type in 0.0.0.0. This would be the same thing as saying area 0 that we configured on our core switch. Next, we need to define the type of area this will be, and the options available to us are the following. There are normal, stub, or a not so stubby area. So in our case, this would be considered as a normal area, so we'll select that. Now let's go to range, and this will specify which networks on our firewall we want to add into this area. Let's go to add, and this will be the interconnection network that we did on our core switch, and that is 172.17.99.0/29, and for the action, it is advertised. We want to advertise that within this particular area. Once we're done, we'll click on OK, and we can add other networks that may be connected into this area. Now let's go to the interface tab and go to add. And this will specify which interfaces we want to add into this area. First things first, we need to select the interface that we want to include in this area, and that will be our LAN facing interface, which is Ethernet 1.2. Once you do that, you want to make sure that it is enabled for OSPF, which it is. You'll also see passive, and we want to make sure that we do not check this. If we check this, then our firewall will not establish a new neighbor adjacency with our core switch. For the link type, we have the options of broadcast, point-to-point, and point-to-multipoint. We're going to select it at broadcast. and we'll leave all the other timing and metric details alone. So once we're done with this, we'll click on OK. We'll say OK again to add the area, and OK to apply our OSPF configuration. And now let's commit these changes. Okay, so everything has committed successfully. Here on this page, we'll see that under OSPF that it is enabled. We have added one area and one subnet, and that we see one neighbor has been established. That's good news, but let's confirm that from the core switch itself. Let's bring up our console session, and here on the console, we do see that. We do see that a new adjacency has been established with 99.1. That is the IP address of our firewall. We can also confirm this by typing in the command show IP OSPF neighbor, and that will confirm the same information. Now, if we type in show IP route to look at our routing table, you'll see that there should be no OSPF routes because nothing has been advertised from our firewall to our core switch. However, our core switch should be advertising our user network and our server farm network. That can be confirmed if we go to more runtime stats for our virtual router. And here for the routing table, we do see that. We see 172.17.101 and our 201 network. The next hop is 99.2. That is the IP address configured on our core switch. And we know that this is OSPF because for the symbols or for the flag, it reflects an O, which is for OSPF. We can get more details if we go to the OSPF tab. And under summary, we can see information of our router ID. And if we are operating as a ABR, that means we are connected between different areas, which we're not. We are only connected into area 0. Or if we are an ASBR, that means we're connected into OSPF, but we're also connected to some other type of external routing protocol, which is true. We have a default static route configured, so it is treating our firewall as an ASBR. If we go to the area tab, we can see the details of what we added in our configuration. You see the area ID, the range, even the area type. If we go to interface, we see the interface that we added, including the type, even the address configured on that interface. You'll also notice that our status is that we are a BDR, or a backup designated router. We can look at other details on this particular page on the intervals, but we also see details of the DR IP address, which is our core switch, because it has the higher IP address of 99.2. So that provides a lot of good information that you can see here. And of course, if you go to the neighbor tab, this will show basically very similar results that our Cisco switch has. We see the neighbor address, the neighbor router ID, and other information here that's very important. So when you're configuring OSPF, you want to confirm if you have a neighbor established, but then go to more runtime stats and view that information. Look at the routing table, look at the OSPF neighbor and the interface details. But we're not done yet. Let's go back to our core switch. And looking at that routing table, if you remember, we have no routes present because our firewall is not advertising anything to us. But we're going to change that. We want our firewall to advertise to us a default OSPF route. So to do that, we need to redistribute our static route on the firewall into OSPF so then we can receive it. So to do that, we need to do all this on the firewall itself. We need to go back to our virtual router, and we need to go to redistribution profiles. Now let's go to add, which is here at the bottom. And you'll see a lot of information here, but let's go through the important details. First things first, we need to define a name, some descriptive name. We're going to call this something like RH-RP for redistribution profile static. For the priority, we're going to say priority 1, the first one in our list. For redistribute, here on the right, we're going to check redistribute. And for the new metric, we're going to type in a number of 10, something simple. For type, we're going to select type because what we're going to redistribute is going to be a static route. Well, the only static route we have added is our default route. So we need to add that here under destination, which is 0.0.0/0. That's our default that we've added in a different step. So we want to make sure we have added that. We'll say, okay. So then now that profile has been added. Now we need to associate this profile to our OSPF routing process. To do that, let's go to our OSPF tab. Let's go to Export Rules. Here, let's check Allow Redistribute Default Route, and let's go to Add. For the name, we're going to select the profile that we added earlier. For the new path type, we'll use the default, which is external to, and we're done. Let's click on OK, and then OK again. Great, once we're done, let's commit those changes. Let's close that up. Now making these changes will reset our OSPF neighbor. So that's why you see a neighbor count of 0. Let's go back to our core switch. And we want to confirm if we are receiving our OSPF default route. So nothing yet, nothing has been advertised to us yet. Let's wait a few seconds and then let's go ahead and try again. Let's try it now. And there it is. We are receiving an OSPF default route from our firewall. So that is how you can configure OSPF and route redistribution into OSPF on the Palo Alto Networks firewall.